We are the Group 2 and we will be reporting the experiment number 4, the qualitative test for elements in organic compounds. I am Avaninia V. Sumojo.
I am Joanna Faith M. Pacleb.
Hi, my name is Nalhara Makaken.
I am Charlene Claire E. Larito. Shaina Joyce C. Ibrahim.
I'm Eliza Saga.
Qualitative test for elements in organic compounds. The predominant elements found in organic compounds are carbon, hydrogen, and oxygen. The next common elements are halogens, chlorine, bromine, and iodine, sulfur, and phosphorus, while the less common ones are arsenic, mercury, and other metals. Carbon and hydrogen are detected qualitatively by heating a mixture of the given substance with dry copper oxide in a glass tube. The organic substance is oxide and carbon dioxide and water are formed. The presence of carbon dioxide is indicated by the formation of the white precipitate of two calcium carbonates when the gaseous products are passed through a solution of a lime water. The presence of hydrogen is indicated by the formation of droplets of water in the tube.
The presence of oxygen is tested with the use of Ferrox paper, which is prepared by soaking filter paper in methanol-containing compounds. The complex FeCNS gives deep red-colored solution, as it is distributed between the filter paper and test compound. Solution of compounds which do not contain oxygen remain colorless. The detection of nitrogen, halogens, and sulfur is made difficult by the nonpolar nature of organic compounds since they do not ionize solution to give ions of these elements.
For this reason, it is necessary to convert these elements into inorganic ions before making qualitative tests. The conversion is done through fusion and metallic sodium, which composes the organic compounds and soluble salts of the above elements are formed. The reaction is represented by the equation organic compound carbon, hydrogen, oxygen, nitrogen, X, S plus sodium, fusion, NaC and NaX and Na2S. Note, X represented the halogen Ci, Br, and I.
The resulting ionic compounds are then tested qualitatively for the presence of nitrogen, the halogen, and sulfur. Nitrogen is usually detected by the formation of the Prussian blue after the sodium fusion. Nitrogen in cyanide form is converted to sodium ferrocyanide, which produces Prussian blue, ferrocyanide, Prussian blue with ferric chloride in acid solution. If nitrogen in the given substance is in form of amino, heating with the soda lime, a mixture of fused sodium hydroxide and calcium oxide will liberate ammonia gas, which is tested with moist red litmus paper.
The halogens are detected by the Belsen test. An organic compound imparts a green-colored flame when burned upon the surface of copper wire reacts with the halogens to form the cuprous halide which burns with a green flame. Another test for the halogens is based on the formation of an insoluble silver halide upon treatment with silver nitrate solution in the presence of dilute nitric acid. It is necessary to remove cyanide and sulfide ions by boiling the original test solution with dilute nitric acid. Otherwise, these ions form precipitate which interfere with the detection of the halogen. Silver cyanide is white and silver sulfide is black. The silver halide gives white to yellow color. The presence of sulfur is detected by the production of brownish-black lead sulfide when the test compound is treated with lead acetate in the presence of acetic acid. Acetic acid prevents the formation of other insoluble lead salts. With sodium nitroprusside, the sulfide ion produces a red-violet color which fades somewhat readily, being a delicate one in cases when there are strong evidences for the organic nature of a substance. Qualitative tests are only for elements other than the carbon hydrogen.
The procedures. Number 1. Test for carbon and hydrogen. A. Mix thoroughly 4 grams of copper oxide and 2 grams of glucose. Place the mixed elements in a dry ignition tube. B. Fit a cork with a bent glass tubing in a test tube containing ml of clear lime water. See diagram set up apparatus for C and H test. C. Clamp the ignition tube and heat it with a moderate flame. Observe what happens to the lime water. Number 2. Ferrux paper test for oxygen. Letter A. Prepare 4 dry test tube as follows. Test tube number 1, 15 drops of acetone. Test tube number 2, 15 drops of benzene. Test tube number 3, 15 drops of ethyl alcohol. Test tube number 4, 15 drops of gasoline. Letter B. Put a piece of dry Ferrux paper into each test tube. Letter C. Observe change in color of the test compound and Ferrux paper. Number 3. Test for halogens. A. Bilston test. Make a small loop on the one end of a copper wire and heat the loop in the Bunsen flame until no more color is imparted on the flame. Cool the wire and dip it in chloroform. Heat again in the Bunsen flame. Observe the color in the flame. Letter B. Silver nitrate test. To 1 ml of chloroform, add 1 to 2 drops of 5% nitric acid and boil gently for a few minutes. Add 10 drops of 1% silver nitrate solution. Note the formation of turbid or cloudy solution. Number 4. Lead acetate test for sulfur. To 1 ml of 5% albumin, add 5 drops of 10% NaOH and 2 drops of 5% lead acetate. Boil over a water bath. Note the color of the precipitate form.
For the observation, first test for carbon and hydrogen. The lime water turns into yellow. It has a bubbles in water and very and there is a presence of hydrogen, since there is a bubbles in the water. Second, Ferrux paper test for oxygen. When you add 15 drops of acetone in the Ferrux paper, the paper turns to red in the first test tube. When you add 15 drops of benzene, the Ferrux paper will turn into violet. Same also into 15 drops of ethyl alcohol, it will turn into violet. Lastly, when you add 15 drops of gasoline in Ferrux paper, there is no changes. Therefore, those Ferrux paper that change its color, it means there is an oxygen in the Ferrux that has no changes of color, it means there is no oxygen.
Test for halogens. The observation of Wilson's test. The color of flame in the Bunsen flame of copper wire was turned into green. Then the silver nitrate test. There is turbid solution or cloudy solution was observed in the silver nitrate test.
Lead acetate test for sulfur. Observation. The color of the precipitate formed from yellow, it turns into brown. From brown, it turns into dark brown, and eventually it turns into black. It is the final color of the precipitate form.
For the question number 1, write the chemical reaction involved in the test for carbon and hydrogen. Glucose plus copper dioxide yield to copper plus carbon dioxide plus water. Question number 2, what is the white precipitate formed in the carbon and hydrogen test? The white precipitate formed in the carbon and hydrogen test is calcium carbonate. Question number 3, how is hydrogen detected in the test carbon and hydrogen? It detected by the presence of bubbles in the water, since according to the observation, bubbles represent as hydrogen. The presence of hydrogen also is indicated by the formation of droplets of water in the tube. Question number 4. Write the structural formula of acetone, benzene, ethyl alcohol, and octane, the major compound of gasoline. Question number 5. Why is sodium fusion necessary prior to the qualitative test for elements other than C, H, and O in the unknown compound? It is necessary to convert these elements into inorganic ions before making qualitative tests. The conversion is done through fusion with metallic sodium, which decomposes the organic compounds and soluble salts of the above elements are formed. The resulting ionic compounds are then tested qualitatively for the presence of nitrogen, the halogen, and sulfur.
For the question number 6, what is the gas evolved in the soda-lime test? If nitrogen in the given substance is in form of amino, heating with the soda lime, a mixture of fused sodium hydroxide and calcium oxide will liberate ammonia gas, which is tested with moist red litmus paper. Question number 7. Account for the change in color of the litmus paper in the soda lime test. The presence of oxygen is tested with the use of a ferrox paper, which is prepared by soaking filter paper in methanol-containing compounds. The complex FeCNS gives deep red colored solution as it is distributed between the filter paper and test compound. Solution of compounds which do not contain oxygen remain colorless. Question number 6. What element is responsible for the green flame produced in the Bilstein copper test? The halogens are detected by the Bilstein test. An organic compound imparts a green-colored flame when burned upon the surface of copper wire, reacts with the halogens to form the cuprous halide, which burns with a green flame. Question number 9. What element is responsible for the cloudy solution in the lead acetate test? The presence of sulfur is detected by the production of brownish to black lead sulfide when the test compound is treated with lead acetate in the presence of acetic acid. For question number 10, what is the chemical composition of the precipitate in the lead acetate test? To 1 ml of 5% albumin, add 5 drops of 10% sodium hydroxide and 2 drops of 5% lead acetate. Boil over a water bath. Therefore, the color of the precipitate formed from yellow, it turns into brown. From brown, it turns into dark brown. And eventually, it turns into black. It is the final color of the precipitate formed.
As a conclusion, we come up with some observations during the experiment of different qualitative tests for elements in organic compounds. First, in the test for carbon and hydrogen, our observations were the lime water turns into yellow one and it has bubbles in water, so it means there is a presence of hydrogen. Next, in ferrox paper test for oxygen, we observed that if we add 15 drops of acetone in the ferrox paper, it turns into red in the first test tube. And if we add 15 drops of benzene and ethyl alcohol in the ferrox paper, it will turn into violet. And lastly, if we add 15 drops of gasoline in ferrox paper, there's no changes at all. So it means those that changes color has an oxygen, while the other that has no changes means there's no oxygen. Additionally, on the test for halogens, our observations of the Bilstein test, the color of flame in the Bunsen burner flame of copper wire turns into green. And in terms of simple nitrate test, there is a turbid solution or cloudy solution that has been observed. And also in lead acetate test for sulfur, we also come up with some observations such as the color of the precipitate form from yellow until it turns into brown, and from brown it turns into dark brown, and it turns into black, and that was the final color formed by the precipitate. Finally, it is very essential and necessary to convert these elements into inorganic ions before making qualitative tests.